second lecture of the iOS team lectures, series of lectures. And this time we'll be talking about Objective-C Primer. But just to remind you that we actually recommend that you actually look at the MVC, or the Model View Controller design pattern, as well as the object-oriented programming pattern as well, because these are important concepts that will be needed in order for you to completely understand what the structure of the whole iOS programming is all about. So I recommend you to check that out. Just go through Google, or we'll also provide sources as long as you are part of our mailing list. So first off, I would like you to register on by sending an email to our iOS director. His name is Tamer, and his email address is iosdev@uftdev.ca. And so you can contact him. Just give him an email, give your name, email address, and possibly your experience about different languages, so that we have an idea of which students we have so far. So I would just like to remind you of that, and also to get more resources, especially regarding for iOS, we recommend you to actually register for free to Apple, an Apple ID for in developer.apple.ca, or .com rather, so that you can have access to the free resources that they provide, which they do have good resources as well to supplement these lectures. So just to start up here. Okay, so just to start up here, we have I will be starting with the Objective-C Primer, which is based on an Apple's documentation on their take on learning Objective-C. So this wouldn't be a cover pretty much of what they have there, but you could refer to the link below on the slide for more information. So let's get started. Okay, so this is just a small screenshot of what you'll see when you actually visit the site for the Objective-C Primer that Apple provides, which is again free. So just to note here, Objective-C is actually just a superset of the ANSI C programming language. So if you're familiar with C syntactically, or I mean even the ideas too, which would be really important, as well as Java, if you know Java as well as syntactically, it would be it would be in a great advantage for you to learning Objective-C. But if you don't have the experience in both of these languages, starting with Objective-C, I believe you can get by to it. It would take a lot of time if you're actually just starting to program, but Objective-C will be a much different language compared to the other ones, like C and Java and other languages syntactically, so meaning in terms of like how you call methods and all that. Also, Objective-C is just an object-oriented. It combines object-oriented principles with the C programming language, and which gives you Objective-C. So it's just all the C ideas, concepts that they offer there, plus the object-oriented principles that I suggest you have to take a look at if you're unfamiliar with that, so that when you approach Objective-C, you'll understand what we mean by classes, methods, and properties, and etc. So to making a file for Objective-C, we have two file structures. So they are called header files and implementation files. So we'll start with header files. So for they usually end with a .h extension for header files, and we have the file. Okay, so this file is just containing all your declarations of instance methods or class methods, as well as instance variables. So that other classes that creates an instance of this class that you're actually creating have access to these things. So as long as you declare it on the header files, they would have access to all your instance methods, instance functions, and as well as your class methods. So I just correct that. It should be instance methods rather than instance functions. So just to clarify that. But if you're coming from C, functions are the same as methods, but they're just like in the object-oriented programming lingo. There you go. So that's for header files, and for implementation files, this is where you basically place your implementation. So that's why it's called the implementation file. It ends with a .m file, and remember that that you just basically implement your methods here, anything that you declare on your header file. Okay, and this is where you usually synthesize your variables. I didn't talk about properties, but as you'll see in the next few slides, I'll talk about properties. So I would just like to go into the header file structure right now. So as you can see from this picture, this again from the Objective-C Primer screenshot. Uh, as you can see from the member variable declarations with the curly braces, right? So those in between are your member variable declarations, or the instance variables, as we call it in object oriented lingo. Okay, so that's the those are the instance variables. But these days again we use properties, and I'll show you a little bit, a sneak peek of it, and I suggest for you to explore more about properties, which are very helpful when you're actually doing object-oriented programming. Okay, and so that's how we declare instance variables. But now again, we use properties, and we have method declarations. Every single part of the method declarations have a meaning. Okay, and I will talk about that in the next few slides. I would just like to note that at interface, that's what we call a directive. What it basically means in this file is that usually the header files will start with a .h file, and this is your interface, your where you actually show to everyone that has access to this class, or the one to the class that imports this class rather, that this is the header file, and that's what it basically means. An interface, when you see it, it would be a header file, and and then you have your class name there, which could be any name that you want, and then you have this colon right there, and then after the colon, this is where you define which parent class you actually want to inherit. This is one of again part of the object oriented um, uh, idea here in terms of inheritance. So if you're familiar with that, ns object is similar to the, I believe, your root class on your Java, which I forgot at the top of my head, but pretty much ns object is your root class in this case. Okay, so those are the parts. At n is also again a directive that signifies, oh, this is the end of the header file structure. So that's for the header files pretty much. Again, so I would just like to show this, as you can see on your right, that in this snapshot of what we did on the first lecture, the basic calculator, we have actually, instead of having those curly braces, right, as you can see from this previous slide right here, that I have add properties here. This is what we usually use now when we're actually declaring instance variables, and I suggest you look at this Apple's guide for Objective-C Primer. It has this section called Declared Properties. I would highly recommend to take a look at this and follow their links if you want more information about the properties as well. Okay, so this is pretty much the difference. You know, we have the import statements. Pretty much all these directives, these parts right here are pretty much declared for you, except for obviously the instance variables and the methods that you have here. Okay. So we'll go to the different types of variable typing. So we have strong date type variables. So what do we mean by strong date type variables? Well, in C or Java, or okay, so we can go, okay, so in C, so we have an integer. So if we want to define an integer, so we go int, and then we'll call it to a variable called mynum. So what that means is that this mynum would contain a value of type integer. So in similar case here, strongly typed variables, meaning that in this example, n is string, that student name will hold an n is string value of some sort. Well, to be more technical, it's actually a pointer to the n is string object. So just you can get by to this without knowing the pointer, which comes from C. Again, that concept comes from C. That the star before student name, so that comes from C. Again, a pointer. We're working with pointers. So if you're not familiar with pointers with C, or if again you don't know C at all, if you're declaring, let's say, a string, like in this case n is string, just don't forget the star to put it in before the variable name. Okay, so just in this case, I'm declaring a string, n is string. Okay, it's just an object. Again, n is string is just an object, and it's a pointer to it holds a string value. You could say, you could think of it that way, and it's called student name. Okay, and it would never change if you pass in something of some different type. Then it would not take then the compiler would detect it right away for you. Okay, so so that's how you declare it. So again, semicolon just to end it, right? Okay, so weekly type variables, ID. So again, ID is just, it doesn't point to anything. I mean, sorry, it points to it can point to anything that it wants, but when you're programming, you can pretty much declare everything as type ID. So I can even declare from right here from the previous slide right now that student name could be ID, and I can place an n string object there. So that is not recommended. That's not a good way of programming. So we're just going to show it to you here because ID is actually used in several of the some of the APIs that that Apple has for each of their different features, or when it comes to different UIs, which actually like for tables, etc., etc. So this would be important. So for weekly type variables, you don't really specify what type this object will hold during declaration. Okay, and as you can see here, I just noted that there's no star, the star symbol before the variable name of which is called what we call in this case any object type, right? Okay. So then we come to methods and messaging. So again, methods, again, it's just a term for functions. Messaging is just a way of sending. It's just a way of calling function. That's what we mean by that. We'll talk about these terms later on. So as you can see again from the screenshot that we have, again, this is each and every part has a functionality here. So at the very from your left where it says method type and identifier, there's only two types. There's the minus, which means it's a instance variable, and then plus is a class variable. So we'll glance through it in a little bit later on in the slides. Okay. So inside the parentheses, after the method type identifier is the return type. So you could put an n string there, like from last time. Again, don't forget the pointer idea here. So we'll go back there later on as soon when I show you how to create the files themselves and how they look like. So in this case, it doesn't return anything. So void means just doesn't return anything. Insert object. And then at index, so those are what we call the method's signature keywords. So when you call these guys, this method in particular, you go insert object at index, not just insert object by itself, because at index is also part of the method name, pretty much, or the method signature. And we require each of the arguments to be specified. Okay, so an object again. It's the argument name, and then it has a type of ID. And for after it says at index, NSU integer index means I will hold what do you call this an integer, unsigned integer. So that's what NSU integer means. NS unsigned integer. So index would be an unsigned integer, NSU integer type. Okay, and then an object is just again, it can point to any object. Okay. So those are the basic structures for declaring or when writing a method in your header and your implementation files. Okay. The only difference is that again in the implementation file on the where it ends with a .m extension, that's where you actually do your implementation of that file. So again, methods. So self-documenting. So we wanted our methods to be self-documenting. I'll show you what I'm trying to say here is that that there are methods that have really long names. So it could be annoying for you as a programmer, but in Objective-C and by Apple and in the iOS world, we do recommend of writing self-documenting a method signature so that when you read it, it's just pretty much like plain English. Okay. And also, as I mentioned in the previous slide, again, I'm just going to glance back here. Method type identifier. I just mentioned in here in the second point, minus means an instance method. So when you define a class already, and then you declare, you start with a minus, meaning that you can only apply that method to an instance of that object. So that's what it means. well, the plus means if I put a plus instead of the minus from back here again, if I just change the method type identifier from the minus to a plus, then what that means is that it's going to be a class method. So I use the class name. So if I just glance back here, let's say I'll use the example from BC expression. So if I use BC expression later on, I'll call it without an instance of the I don't need an instance. That's what I'm trying to say. When you're calling a class method, you just use the class methods, the class names, the class name, um, obviously corresponding to that class method, so in order for you to use it. Okay. And the colons, as you can see, I'm just gonna glance back here again. That the colons actually separates the method signature keywords and their arguments too. Okay. So now, so I'll show you some of these declarations right here. So we have a method here that takes one argument. So it's an instance method, as you can see from the very left. So you can see it's a minus sign or a dash sign. It returns nothing because, again, void means it returns nothing. So going from left to right, that is. So, and then check value is the name. So check value colon, and then we take one argument right here, which is called current value, and it has type n as integer. Okay. Um, so so that's for the first case, and then for this method right here, for the one below, the second point, a method that takes no arguments means that that there's no colon, as you can see it from the very end on the right. So print my name, and there's just a semicolon, which means that it doesn't take any arguments. You cannot see the colon in there. So and it, but it returns some type which is called string, as you can see here, string star. Okay, and it's an instance method too. So here are just some basic terms. Messaging is a way for you to actually call a function, pretty much. That's what it's trying to say here for messaging. A message is actually, um, well, messaging is the method. A message is basically just a function. I mean, a method call, pretty much. And to send a message means, again, sending it, back and forth. These are just basically, they mean the same thing, pretty much. So again, if back from our first lecture, if I want to calculate the expression using an instance of BC expression, so BC expression in this case, as you can see from here, it's a class name. We have declared it, and if you think through this, if you think through the header file, I'll declare an instance variable called calculate expression. So I want you to do as an exercise to how you can write the method signature for calculate expression. So here are the specifications for calculate expression. It returns an NS integer type. It returns an NS integer type, and it takes no arguments. So calculate expression, again, it returns an NS integer type, and it takes no arguments. And it's an instance method. So current expression right here, as you can see from the subpoint, current expression is a type of BC expression. So I made an instance of BC expression so that I can apply it to a calculated expression. So it makes sense logically as well, because I want to make an expression that holds the first number, second number, and the operation that I would want to apply, right? And calculate expression, so however you implement calculate expression, how we did it last lecture, or however you wanted to implement it, it would take those values right there, and then it would just perform the calculation and return the resulting value, the NS integer value. Okay, so that's so in this case, what I'm using square brackets. So the first argument, going from left to right, so we have the open brackets, and the current expression is just the instance of BC expression, and then when it goes, and then after current expression, we have when it goes calculate expression. It says here that I'm going to send a message called calculate expression. So I'm sending this message calculate expression to current expression. So what this means is that calculate expression is a message that I'll send to the receiver. So receiver is where we send that to. So in this case, current expression. So if you think about it, the logic goes from right to left. So I'm going to send a message called calculate expression. So message is calculate expression. I'm going to send it to current expression, which is an instance of DC expression, right? So that's the receiver, right? So the one who would receive that message is current expression. Okay. So we just use the the square brackets to just call to make a call to send a message. Okay. So I want you to consider this following signature. Right here, it's making a class method. So just to note that right here, the plus, okay? Right there. From the first sub point right there, it says plus void, etc., etc. Plus means, again, it's a class method. I don't need to make an instance. I don't need to make an instance of wherever hello with name belongs to. I mean, which class it is placed on, okay? So it's a class method, doesn't return anything, and it's called hello with name, and then it takes one argument, and again, as you can see, that semicolon right there. I mean, sorry, the colon goes and a string star name. So it takes a string, it's called, and then you can refer it to your implementation name. Okay, so in this case, assuming that I place hello with name in a class called hello world, I can make a call to that by using just the class name hello world, because again, it's a class instance. Sorry, it's a class method, so I can just use hello world. So hello world, hello with name, and then I'm gonna pass a constant a constant string, or it's just a string, called Francis. So that's so again, I'm using the square brackets to call it. So what I'm trying to do here is, again, send a message. It's called hello with name, and it has an argument at double quotes and then Francis. So that's the argument. So hello with name, I'm going to send I'm going to send a message called hello with name with an argument Francis, and to the class name hello world, because it is a class method. Okay, you don't need to make an instance. Okay, so as I just noted here, on the very last point, when we call this function, we call it hello with name with the colon, because it means that it actually takes an argument. Okay, so again, it's just a iteration of what I said last time, that that you need that colon. For in this case, void hello means that it's an instance method. Again, it doesn't take any, it doesn't return any value, and doesn't take any arguments either. So again, if I make a hello world instance, again, it's an instance of hello world. Right there, it says a type of hello world. I can call hello there, and that's a proper way you call it, given that hello world instance is, again, is initialized of type hello world, right? And so we don't call. So now when we call hello, just referring to it. This will be important later on, as you will, in the concepts of selectors. So there's a difference between hello with a semicolon and then hello without the semicolon. Sorry, hello with a colon, and hello without the colon. So hello with the colon, as you can see, means that it takes an argument. As I mentioned before, that a colon actually separates your arguments. So and also means that you're taking an argument in this case. So hello colon means I need, before you call me, I need an argument. So before you call this method, before you actually send it to some particular receiver, I need an argument here. So the proper way to call the hello is actually just hello. That's it. So that's how you're gonna refer to it without the colon itself. So just to note here, if I want to implement the method calculate expression, so we'll do the following here. So I'd just like to take you through this. Okay, so again, here's just Xcode. We'll create a new project. So I'm just gonna bring up our example later on. So here you go. So new project right here. It doesn't need to be a project. Well, actually, yeah, it does. It's just for, in this case, I'll show you how to actually create a file rather. So if I go new, right there, file, new file, right here, and this just asks, it brings me to this option where it says, what do you want to create? Objective C class. categories, protocols, etc., etc. I'm just gonna click Objective-C class. It asks me what the name of the class is. So if I want the name, call it BC expression. So that would be our object, right? And then again, it's a subclass of NS object. Again, NS object is just your root, where you start basically. This is where you start inheriting from, and you could inherit from other classes too, just like any other object-oriented programming ideologies there. So as you can see, there's a lot more, but again, we're just going to choose NS object here, and I'm just going to say outside here, desktop, okay, right here. So create. You'll see there's actually two files right here. It's called again, it's created in here. So again, I just created a new file. Since we're not creating a whole new project here, I'm just going to create two files right here, bcexpression.h. It actually creates both the which is what we call the header file, which is .h, and .m for the implementation file right here. So again, pretty much the stub code right here, they gave it to you. You're all set. These import statements are used to call other libraries when you need them to. So assuming we have so if you I'm just gonna type in here. So assuming we have a file called BC operator dot h and dot m2, right? So .h and .m. So assuming we have those, we can call them. We can refer to them, or we can call them to this class by adding the following line. So if we want to call it, we're gonna go import. We actually use quotation marks for these because if they are user defined, we're gonna call it # import. Just ignore this star. It's just a comment. So # import BC operator .h. So again, I'm just showing you how this is import statements are used. Again, it's similar to include in C. And then import in Java. So they're all similar, okay? So similar concept right here. So now I can refer to BC operator from here and to my BC expression.m. So it's just a side note here. So just put a side note here, okay? Side note about import, # import redirectives. Just an outline here, so refer to that. Okay, so again, as I told you, you don't need to type at interface again, at end. Again, so on the dialog that I showed you beforehand, I specified the name to be BC expression, and that's where it comes from. That's the class name, and it inherits from NS object. Okay. So I'm not. I can put these things here if I wanted to, and then start typing and first num, all that. But again, I'm going to use the idea of properties here, so I'm just going to declare three things here. So a property atomic. Again, if you read about declare properties, then this would be much more clear to you and what these things actually do. So so as of right now, if you don't have any idea about what properties are, I would actually want you to think of it as just I'm making an instance variable, but it's just in a different format right now. So I'm gonna call so and it's an NS string type. I'm gonna call it operator. So this basically means I'm gonna create an instance variable called operator. Okay. So instance variable called operator. And then we're just going to do the same thing here. So non-atomic, and then we're going to go NS integer. And then we're going to first num. So again, same idea, instance variable called first number. Property, non-atomic, NS integer, second num. So we have these things right here. We have three things right here. So you have an operator called NString. Sorry. Okay. So NString, and then we have another instance variable. So we just copy this instance variable called first num, and then we have another one called second num. Okay. So that's what it is. So um, and I'm also going to declare usually the order of these things, again, instance variables first, and then so if you're wondering what the order is, so I'm just going to put here order of declarations. So if we're going to instance variables, okay, or properties, okay, properties first. Gonna put an order here. Then two would be what? Okay, two would be your methods, class or instance methods. Okay, second. Okay, so just a quick note here. So just so you know that there's actually an order, so you don't need to go back and forth. Okay, so I just want to show you. I'll declare um, an instance method. Again, it's a plus, it's a minus sign, not a plus sign. Okay, minus sign, and it will return an integer right here. So that's the first parentheses right here, and it's integer, and I'll call it calculate expression. Okay, and doesn't take any arguments, so I'll just end it with that. So that's it. So that's pretty much it. Pretty basic. So what I've gone through so far right now is that again, we have the interface. So these are this and this line. So these things right here are already declared for you. No need to worry about them. So uh, um, we also have instance variables here. So we have three. We have one type string, some string. It's called operator. We have the some integer called first number and an instance variable called second number. Okay. And the last thing here that we did was that we declared an instance method. As you can see from the minus sign, it returns an NS integer. Just so you know, right here, NS integer, and it's called calculate x. Oh, sorry, and it's called calculate expression. So note that this is called, okay. So the above method is called calculate expression. Okay, you see, no semicolon. Okay, why? Because 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 it does not take any arguments. Okay, just so you know why it's called calculated expression. Okay, not calculated expression colon. Okay, so I would just like to remind you those little small things because they're going to be important later on. Okay, as you expand your knowledge about Objective C and throughout iOS development as well. Okay, so uh, so we're gonna go through the next file right here. So as you can see, there's another one import right here. Just so you know, when you're importing something in here, you could import it here. So let's say BC operator, you can just put this line in here or in here. But if you just put it in here, you wouldn't have any access to it in this file on the header file. Okay, just a quick little note. Again, if you want to explore more about these directives, the import p directives, you search it up. You will find more things about it. Okay, so that's for your header file. Now we're gonna go to the implementation file. As you can see, it ends with a .m right here, and again, just basically says here. Oh, okay. So now I'll declare all the things that I'll implement all the things that I've declared in BC expression.h, which is again all these things right here. So again, just to make it more clear, I need to so every time you use at property, you'll need to use at synthesize here. So I'm not gonna delve into that more because again, it's part of the properties ideas in Objective C. So I would highly recommend for you to take a look into that. So at synthesize, I'm just gonna do it right here very quickly. Use operator, right? So just gonna check back and forth here. Okay, it is operator, as you can see. And then we have first num. So first num, second num. Oh, sorry, second num. Okay. It usually actually shows it, pops it out to you when you actually type a little bit of the code, because the ID would actually find it. But I don't know why not in this case, because I'm actually just probably creating a file here. Excuse me. So now, okay, so we have this out of our way. So now, if we imagine again, when you're actually implementing something, you obviously need to know which method the compiler needs to know which method you're declaring and which implementation you have, right? So to do this, we have just have void calculate expression, expression. So that's it. I just copy, instead of having a semicolon here, I just have squiggly brackets right here, right outside, and then this is going to be implement. So this is where your implementation goes in. So it's pretty much the same structure again. Instead of at interface, at implementation, it's called basic expression. Again, I don't need to specify that it is a subclass of NS object, because I did it here already. So there's no point of doing that. So that's how we do it. And then again, I just did the add synthesize again, just for the sake of the add properties on this side. Okay. And so we have the void calculate expression here. Again, this is where implementation will go in, okay? So that's pretty much it for the structures of this file. Now, I want to delve into a little bit of what Tamer did in lecture 2. So just minimize this. Just like to delve into what he actually did for his demo right here. So we'll just kind of like start it up right here. Start up right here. So here comes our iPhone iOS simulator right here. So in this case, what we're actually, the point of this is that we're this iOS project will eventually delve into the Nextbus application, which you can check at at our current website. It's www.uftdev.ca, and it's under resources, and under iOS you'll see the My Nextbus project app. It's just basically an app that uses a particular service called the Nextbus service, My Nextbus. And if you type in a bus stop ID, it would actually eventually return to you the arriving times to those from that bus stop ID that you just type it into. So we'll delve into that, and this is one part of it. So this the whole concept of a simple browser is that I'm just that we're just sending services. We're just gonna type a link here. So as you can see, http yahoo.com. So as soon as I type this in and press go, I would see all the HTML code, all what the web browser actually sees, and before it interprets it to the web page that we usually see as as users. So if I just press go here, hoping it works. Okay, so all things great to go. So as you can see, it's just these are just HTML code, all that stuff, all that good stuff right there. So the point of this is just that we're querying through that, and that when you query to that and it gets back to us, oh hey, these are the results. Okay, so this is just the sample of that. So just to go back here, I'll explain to you one by one. So first, you actually arrive from this point, or where you actually create the app. So I'm just gonna switch to what we call the assistant editor. So what assistant editor means is that whatever the corresponding file for this particular view is, I'm just going to look through it at the same time. Okay, so it's just right there. Okay, I'm just gonna scroll here. So as you can see, it is really evident right here that that in our this demo this lecture demo app, what Tamer actually approached this to be was that he just actually pressed control and then dragged it from here to that. I don't want to do it because again, as you can see from these little circles, it verifies which outlet this goes to. And as you can see, this is an outlet right here that corresponds to that. Just so to remind you, an IB outlet or an outlet is it's just it's just a reference to your views in this side in your user interface. So what this allows me to do, going ahead a little bit here. The text address. I want to take the address, the text that I just typed in. So when I type in http www.yahoo.ca or .com, when I type it here, I want to get the text right from here from this IB outlet. So that's why I need that connection, and I just place it here in the interface file. So that's the idea that for that. And as you can see, it uses the add property. Again, it's just I guess the modern way of doing instance variables. So, and I just again did it. So as you can see, I can verify it again. I could just control from here and then just drag it to here. So I'm not going to do that because it has been actually connected. I don't want to connect it twice. So so you can see the connections right here. Oh, it's connected to the text address, and then this one is connected to the text view. So which basically we're gonna show our results. Okay. So we're just gonna bring it back here. As you can see, I'm just pressing these things right here just to hide and close panels right here. So I'm just going to go back to so view controller.h is the one that you just saw before. Right here, it's just the connections, the IB outlets. I'm just going to go to .m very quickly. I would like you to see this this special method right here. It's called IB action right here, where you can actually see this more we're connected is in this button. I don't want to change anything here. I don't need to have access to change anything in this, so I don't need a reference to this button right here. But I needed to do something when I press go to it. So that's the whole idea of action right here. An action, as long as it is wired properly to the appropriate view, or in a particular button, etc., etc. When it is actually wired properly to that particular view that you want it to get called. So like this IB action right here. So when this is wired right here, when this IB action is wired to this, is actually wired to that. It seems like you see too, but again, it's just this is wired to that. So I can verify this wiring just so by doing a right click here. Again, as you touch up inside right here, I'm just gonna expand it a little bit. It's called button go right there, and it's button go right here. Okay, so an action again is just an event. So when the user actually presses the go button, when he or she taps the go button, this action or this method, and it's an instance method, will get called. It will get called when you actually touch that button. So when it says here, just press a right click here, as you can see from sent events. When it press touch up inside, so touch up inside is just so you have more. Again, you have more actions right here that you could wire to different IB action or action methods. But in particular, touch up inside is more of your general user tapping the button, tapping this and that. So that's more of the general default action right here. So which is what we want in this case. So we just leave it as that. So again, just press right click on that so you can see that. Okay. So again, every time I press go, this will get called. Every time I press go, this will get called. Okay. So again, every time you type a link, press go, boom. It's just gonna call this button go. Okay. So as we delve inside to the button go implementation, I'm just going to go back to the full code right here. I just want you to notice that in his implementation, he made a string object, right? And a string, again, it's a class. It's a class. String with string, it's a class method. So if we delve into more how you can see this, we're just gonna go press help from Xcode, help, documentation and API reference. So this will bring us to the what we call the organizer, and then we have the documentation. So as you can see, I just there's one book open, I guess, of what this is and all that. So we're gonna go search it up NSString. So it is really helpful. So right here, it's gonna call NSString. It's right here. So it finds NSString for us. Hopefully, we can go here on. It's usually supposed to be here, but you can go to the NSString, I believe here. Okay, it's probably been organized. So okay, so right here they have all these things that they talk about right here about this class NSString. So NSString, the overview, all these things right here. So and eventually you'll get to all the methods. You can see all the plus and minuses. So again, string, this means that I call NSString. So I can just call NSString here. If I want to declare just a string, empty string, it doesn't matter. So and these things are your instance methods, class methods, and then you have instance methods. You have a mix of both here. Okay, so I just just wanted for you to see this one. Okay, string with constants of yours. So this is that class method. Again, it's a class method. You can just confirm it here. Sorry. So just confirm it there, and you'll see again it takes some URL. Okay. Um, or rather, so right here. So for string constants here, I'm getting ahead of myself. So we'll just keep this back as a reference. But I just want you to know that that's why he's making an NS URL in this line of code for this highlighted one, because sorry, I was just distracted by this one. So I would just like to note you to that again it takes in a URL. So again, string with string, again, if I just go up back there again, I can go back up. So just pass back here. If we go down here, you can see string with string. Again, it's a class method. I can just verify it for you right there. And it accepts some string. It could be a constant string or another variable with type NSString. Okay. So again, in this case, what Tamer did was he typed self, which refers to the instance of the class. Again, this relates to the object-oriented principles. And text address, again, I would just like to remind you, text address is just right here. So if I just go back on the .h file, as you can see, text address is, again, it's just the text field, as you can see from here, UI text field. So user interface text field, that's the text field on our storyboard right here. This is just this, okay? So I'm just it says basically here, give me the text here. Give me the text here. So it says here, on my text field, give me the text. That's it. So this whole thing would be evaluated to some string, whatever is in there. It could be an empty string, it could be a link, all that. Okay. So so what this does is basically, I'm going to initialize a string. This is what just basically it's saying. String with string basically means an initializing string. So we're just gonna refer back to the documentation. Returns a string created by copying the characters from another given string. So right here. So imagine this is your link. What this class method will do is just it will copy, again, it says you copy the characters from another given string and place it to this variable called NSString. So it has NSString type, website address. Okay. Just a side note here, nslog means it's just your console here, your debug console, so you can print things here. So if you know the printf statements in C, again, it's just pretty much the same thing. Just so you know, %at. So we have different types: %t for integers, %c for characters. %at is for objects, and that's how you print the value of objects right here. So since remember, anything with NSString, so like NS something, these are objects. In Objective-C, these are pretty much basic objects, unless you're dealing with some low-level C APIs that Apple has included in here for iOS. But otherwise, they're pretty much objects. So that's why we use pretty much %. Okay. So that's for that. And again, I just to pop it out for you right here. Again, as you can see, these are the results right here. I'm just showing you this is the debugger. So if I can probably get into that. So again, address right here. See this line? See this line right here? It's the same. It just comes out to be like this. It's just this line right here. So it gives you a timestamp right here when it happened, all that stuff. And it says here address yahoo.com, and that's what I type, right? So just going back to here. You can ignore this for now. What I'm doing right now is I'm gonna make another string called result. And again, same thing for last time, string with concepts URL, but this time it says here, it tells you right away. So this is where I want to emphasize to you that long names are really and self-documenting method names are really recommended for Objective-C and especially for iOS programming too. So right here I can just tell string with consists of URL. Of URL means this argument right here. So it is very clear to me that it probably might take an argument of type URL, some URL. So usually, Apple stuff they actually for for historical reasons, NS is actually just part of every object. So NS string, NS array when you see later on, all those types. So um, going back to here, it just says here I'm going this if I give this a first look. Um, and if I'm not sure, I can just search it back here to the documentation, right? But by the first glance, I can just see that that this class method again is a class method, right? Because again, as you can see, the receiver is an NS string. It's not an instance of NS string. It's not website address. It's NS string itself. Okay, it's a class method. I can just tell right away. So right here, but again, here I can just tell that it takes some NS URL argument, and I was right here. So it's at the top. Um, it takes some website URL that so it's a class method, so it uses a class method right here and URL with string. So whatever address that I type here will be converted to this NS URL type and will be just placed in website URL. That's what all this code does. And if I go back here, again, it takes a URL, which my guess was right when I referred to this. So takes a URL and then makes and then the string contents of the URL. So basically, what this part does is basically it goes to the website. Hey, give me all your HTML page right here. It starts from right here, as you can see from the debugger. So when I go back, so what happens is that when it gets to here, it basically has all these text. So it's just a bunch of text. As you can see from the debugger, again, I have the debugger output here. It says here result starting from here. That's result means it's just this all constants the URL, and then that's it. Right here at the end, he's just setting the value back to the text to the other property right here. If you go back here, this is where text view. This is where this is where all the stuff will be stored to. Okay. So just it's just a little bit of browse up right here. Okay, so just to show you one more time, could just run this one here. Okay, TP Facebook.com. If I type it correctly, yeah, right here. So as you can see, it has Facebook right here, all the web page stuff. So the whole point of this is that again to show you the idea of outlets and actions, as well as connecting them. Didn't show it step by step, but I've shown you that the connections can be confirmed through these circles right here, and and also retrieving some ID, some web page, like some service or of some sort, which is again part of the Nextbus app that you will need to create. So this is one of the small pieces that you'll actually need. So basically, being able to retrieve something from the user and then using the links and actually retrieving the information and then getting it back to you. So that's one part of the Nextbus app. So well, on the third lecture, me and Tamer were actually planning to do a little bit more towards the Nextbus app, which goes into more of the idea of parsing them. So again, we'll use some service, and then know how to parse them. There's actually two types. Again, we're getting ahead a little bit here. There are two types, and they're called JSON. Is for JSON. So these are for JavaScript object notation. So this is pretty much one of the web standards when you're actually sending and retrieving web data. And we have another one, XML. I believe it's I forgot what the X means, but it's a markup language or some cross markup language, I believe. But that's another web data language that web pages use and other apps use for sending web data. Okay, so that's a little bit ahead. And again, just to remind you that we would like you to send your registrations to our iOS director, Tamer, and if you can send him your name, you could go to the website at the www.uftdev.ca, and if you can go there and then actually see see the website for the iOS team for Tamer, and you just send your name and your email address so we can add you to our mailing list. And we actually had our own iOS team mailing list for U of T, for our group, U of T developers group. So we'll be sending you all the information, all the lecture notes, all the stuff that you need, and more resources, and as well as if you have any questions, you can just send it us through that email address. So we hope to see you on the third lecture, and have yourselves a great day.